In this video, we're going to review one way that you can look for alternative optimal solutions for a linear program. First, let me explain what an alternative solution is. So let's say if for an example, if for a problem, there are two alternative optimal solution, alternative 1 and alternative 2. In order for these two solutions to be alternative solutions, their objective function should be the same. So let's say z and z, so they should be exactly the same. However, their decision variables, the actual decision variables, xi and xi prime, let me just call that one z prime too. So z and z prime, they're the same. The objective function will take the exactly same value for two optimal alternative solutions. However, the actual decision variables are not the same. They're different, right? So for different decisions, you will end up with the same objective function, with the same cost or profit, right? So this is the necessary condition for being able to call two answers alternative solution. And we're gonna just review one way that you can, the Excel file, the solver will always provide you with one solution, if there is any. If there is any optimal solution, Excel solver will only provide you with one of them. You can always look to see if there is more than one, because management is going to appreciate having two ways or more than one ways to reach to the maximum or minimum value of your objective function, right? So it's always nice to have more than one alternative because it gives the management flexibility in terms of choosing the best action. There might be other considerations, for example, that they may think of. So I'm gonna focus on one example that we did before, the transportation example. In this example, if you remember this one, we had 3 origins and 4 destinations, and the question was how much to ship from each destination to each, from each origin to each destination in order to minimize the transportation cost. So we had a limited capacity at our origins. We had a specific amount of demand that they required, each one of our destination or distribution center in that specific example. All right. So we wanted to, while making sure that the demand is satisfied, we wanted to not violate the capacity requirement, the maximum available inventory requirement at each origin, and we wanted to minimize the cost. All right. So we, if you remember, we solved that example, and I have it in the Excel right here. So this was the original. This was the original problem, the formulation, and I have the Excel file. I'm gonna quickly review that as well. But now we want to see if we can look for an alternative solution. So remember, the alternative solution, in order to be called alternative, one cool thing, one very important thing is that it has to have the same objective function. So we can use this. We can actually use this for finding an alternative solution. We can enforce that by letting the objective function, the previous objective function, let me add a star here, star, 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 and star actually corresponds to the optimal solution, optimal objective function, optimal value of objective function for the second solution. All right. So What we can do when we're searching for an alternative solution, we can add, this value, the best value that this can take, we just found, when we solve it, we found it to be equal to 39,500, the total cost. So, and then by the definition of alternative solution, we know that if there is an alternative, its cost is not going to be greater, should not be greater than 39,500. So we can add this as a constraint now. The objective function, the cost, exactly equal to 39 and 5,000, 39,500. And then we just make this fixed equal to the optimum level of cost. And then for our new objective function, we need to force somehow the decision variables to take different values. So we can add this as a constraint, the formula for the objective function equal to the actual value of objective function, the optimal value of objective function that we found. So we add it as a constraint, and then we let we somehow force the decision variable to take different values. One way to make it happen, to make the decision variable to be different, is by pushing the variables that took 0 in the optimality, in the original solution. By forcing them to take zeros, we may end up with it's somehow likely that we end up with an alternative solution. It's not guaranteed, though. This is very important to remember. It's not guaranteed. So let's just review this one more time. So this is the original formulation, and now we want to see how we can generate an alternative solution. So this was the optimal cost. Now, these are the values in the optimal solution that we found that took zeros. Now, if we make sure to maximize the sum of these variables, hoping that one of them, at least one of them, take a positive value, while at the same time, we're keeping the cost equal to 39,500. If that happens, then we actually found an alternative solution. So what we're going to do, we're going to revise the model, alternative search model, to maximization of the variables that took 0 in the optimality, subject to the same constraints, the same set of constraints, plus a cost constraint, an objective function constraint. So before we had an objective function, we found that the optimal value that it can take is 39,500. We enforce this. We don't let it to be less than that. We just make sure that it's going to stay at the optimal level. And at the same time, we're hoping that by this new objective function, at least one of these values will take a positive value. And if that happens, if we find a feasible solution for this, and this happens to be a positive value, which means at least one of these decision variables is taking a positive value, then we have the solution is the problem is solved. We have found an alternative solution. So let me go ahead and let me just, before I go to the Excel and do it, this is the process for generating an alternative optimal solution for a linear program when we are dealing with a linear program, LP. So solve the linear program, solve the original one with the objective function and constraints that you have. And now the alternative search starts from here. You revise the linear program. You want to maximize now a new objective function, which is the sum of those variables that took 0 in the optimal solution of the first step in the original solution. Keep all the constraints the same, add another constraint that forces the original objective function to be equal to the optimal value that you found in step 1 and solve it, solve the revised model. If you find, if you were successful to make one of those 0 decision variables to take a positive value, you're done. You have found an alternative solution. So let me go now to the Excel. This is the problem that we solved. This is our transportation example. All right, so we had 3 origins, 4 destinations. We had supply, capacity, and we had demand for each one of these cities, all right, for each one of our destinations. We solved it. We found the objective function to be the minimum cost, the minimum transportation cost possible is 39,500. And this is our transportation schedule. This is how you allocate, actually how you ship items from each origin to each one of these destinations, all right? 3 by 4, 12 decision variables. Now, so this is my original answer. I now want to see, using the approach that we explained, we want to see if there is any alternative solution. So I'm not going to work exactly on this sheet. I'm going to copy this sheet and we're going to work on that one. So let me copy this sheet first. So right click on here and move or copy. Let's create a copy at the end. And I'm going to call it alternative search. All right, so it's going to be alternative search. Now, I said the changes that we have to make, the objective function, which was originally objective function, it's going to be now a constraint. And I'm going to record this value, 39,500. So I'm going to enforce this to be a new constraint. So it's not an objective function anymore. It's going to be new constraint. It's the new constraint transportation cost to stay at the optimal level. So that's my new, it's going to be a new constraint, but how about the objective function? Objective function, the new objective function, let me just add that one, new objective function. It's going to be, like I said, it's going to be sum of the decision variables that took 0 in the optimality, in the original solution. So sum of these two, these 3, comma, these 2, comma, and this 1. So all of the zeros, and I want to maximize this. I want to maximize. We want to find maximum of this objective function. All right, so I'm going to go ahead and go to Data tab, Solver. So the cool thing about copying your sheet this way is that the Solver parameters are going to be also copied. So I don't need to define the constraints again. So my objective function, make sure to change it to maximum of the new objective, sum of zeros. By changing decision variables are the same, constraints are the same. I just need to add the new constraints, the cost. And I want the left-hand side, which is the cost of the new alternative, to be the same as the exact value of the transportation cost from the original optimal solution. All right, so with this, we can go ahead and solve this problem. So let's see if we found an alternative solution. Look, the new objective function is now 2,500, which means we have made a change. And then the objective function, the actual cost is exactly at the same level, 39,500. So this is indeed, and this is zero, by the way, this is indeed an alternative solution, and it's different from the solution that we had before. Look, we had for Cleveland, we had 1,000 and 4,000 to Boston and Chicago, and now the numbers are different, you see. So now we have, and here Bedford to Chicago was zero in the optimal solution. In the alternative solution is 25,000, and some other changes that have been made to our decision variable. So decisions are different, but the cost is the same, 39 and $500,000. So the cost is the same, decisions are different. So we just found an alternative solution, and it's nice. And you can just keep going and do it again and see if you can come up with a new alternative using this approach. Like I said, it's not guaranteed. Even if you are not able to find, even if our objective function was zero, this is not guaranteed to find you alternative solution. If you find this to be zero, that means this method could not find you an alternative solution. That doesn't mean that there is no alternative solution, right? So this method has its limitations too.